Greetings everybody. So in this video we're going to discuss about how to create functions in MATLAB. Okay, now let me remind everybody this is the MATLAB environment. Here is the command window where I can directly place some commands or call some specific function from MATLAB itself, like cosine or whatever. Okay, here is my repository. Okay, so I have a specific subfolder where I save all of my scripts and functions, as I'm going to show you. And here is the workplace that shows me which are the saved variables inside MATLAB environment. At the moment, I have just the default variable, which is ans. Okay. Now, as you know, MATLAB, of course, has many built-in commands. For example, cosine. It has some other commands. So, for example, if I have a MATLAB here, it has a function to compute its eigenvalues. Okay, and as you know, most of these MATLAB commands, if you're already familiar with MATLAB, have different ways of being called. For example, one function in MATLAB may obtain one input or two inputs or more inputs and may return one output or several outputs. So we can create this ourselves. So we can create a script in MATLAB and save it as a function format, which means that we can call it anytime we like, giving it a specific type of argument, depending on how we define the function. And of course, it returns to us one or more output arguments, or maybe even no arguments at all. Okay. So here I have an example of a couple of very basic functions. I'm going to discuss to you how we can create them. Of course, remember, if you want to create a new file in MATLAB, you click, say, create a new script. So this is a very simple script where you can actually write whatever code you like, save it, and then run it. You can, of course, need to save it in the same place that you are having your repository at the moment. So your current folder needs to include the file that you have created. Otherwise, when you click run or call a function or a script, simply MATLAB will be unable to find it because it's in a different folder and will create an error. Okay, so we create a new, not script, a new function, and immediately MATLAB gives us the shape, or not the shape, the format of the function by its default. Okay, so this is the shape, the format, I'm sorry, for the function. The first line is fixed. Everything else is free. So the first line for all function files should be function space, and then we have this format right here. So we have the name of the function, and inside the parentheses, we have the input arguments for the function. It may take one, two inputs, or no inputs at all. Okay. So here, for example, the default case for MATLAB has two inputs. And then on the left side of the equal sign, we have an output vector, which denotes how many arguments the function gives us as an output. Okay. Remember, when we are calling a function, we are using parentheses, but when we are saving values, we are using this symbol right here, the square parentheses. I think in English it is called brackets. Okay. So this is the standard way that we call a function, not call, sorry, that we define a function in MATLAB. Okay. This is the first important part. The second important part is that you need to save this script in the same name as the name of the function. So for example, if I call this function here myfunc, when I save it, you see by default the name of the file is myfunc as well. If you don't save it with the same name, you're gonna have some issues. Okay, so these are the basics for defining a function. It also includes an end file here, so function starts with a function file, with a function call and ends with an end line. But even if you remove that and you save it, it's still gonna work fine. Okay, just a side note here. And inside the function, we have the arguments along with some comments. Okay, so let's see it firsthand. I'm gonna delete this. And I have a collection of very simple functions that we can use. Let's start with the first one. So this function, f equals Celsius to Fahrenheit. Okay, it takes one input argument, C capital, and returns one output argument, okay, F capital. So what does this function do? Obviously, you can understand from the name of the function. This function simply transforms a Celsius value to a Fahrenheit value. Okay, so it has one single line of code. If you Google the transformation from Celsius to Fahrenheit, you will find this exact formula. I have already saved the function, and I can very easily call it. Let's delete everything. So I call it as Celsius to Fahrenheit, and I give it as an input 100 degrees. And the output is 212 degrees. Okay, some details right here. I can save this to a value. So let's say x equals Celsius to Fahrenheit. Okay, so we can save this result into a specific variable, which is 212, and the variable is named x. So some details here. Okay, if you see this function right here, I have used this Greek question mark, okay, in order to suppress printing the argument. Okay, this has to do with the fact that we don't want the printing of the internal commands when we call the function. Okay, it is different from printing the argument when calling the function. So as you see right here, uh, when I'm calling the function, when I don't use this symbol, the result is printed. Okay, so this is the way the function is called. This is different from including this right here. Okay, if I remove the question mark, the Greek question mark, these results are going to get printed before the function outputs its result. So we don't want that. So usually inside the function, all of the commands have the Greek question mark. Okay, because we want to suppress printing the arguments that are called inside the function. Okay, first information. The second information has to do with the internal variables. So this capital F and capital C right here are internal variables used inside the function. Okay, so these are not present in the workplace, okay, in the command window. So if I have any other argument right here, for example, C, of course, this brings an error because there is no such variable as C. Okay, and when I'm calling the Celsius to Fahrenheit, I can save it into any variable name that I want. Okay, so the fact that here I have the output named as a variable F, this is just the name of the variable that works internally inside the function. Okay, so outside the function, these variables have no sense. F and C, these are local variables. That's how we call them. Okay, they have nothing to do with the overall script file that I'm having or working in the command window. So just like that, I can simply define my own function. Okay, first example is this. Now, let's move to a second example. This is a function called matData. Okay, it takes an input argument, which is a matrix A, and as an output, it returns three arguments: min val, max val, and summation. Okay. So what does this function do? I have some comments here that explain how the function behaves. So what the function does is this. Okay, it returns the minimum, maximum, and summation of the values of this matrix A. Okay. By the way, here is some important information. Again, when calling a singular argument, I have parentheses, and when returning variables, I have square brackets. Okay. The first text that you see right here is very important because it explains what the function does. Okay. When you're creating your own functions, especially if you aim at sharing them with many other people, of course, you need to include comments both inside the code and at the beginning of the function to help the user understand what the function does. But moreover, MATLAB has a very nice property because the first comments that you use right here are gonna get printed when you call help for a function. So remember, if I ask help cos, it prints some information about what the function cos does, which is the cosine, okay, in radians. If I type help eig, it prints some information about the function eig, which computes the eigenvalues and the eigenvectors for a matrix. So same thing right here. If I call help matData, it returns to us the exact text that I'm using right here. Returns the minimum, maximum, and summation of the values of matrix A. And you see right here that just because I have this percentage sign, I have some dummy text right here, this also gets printed. Okay, so all of the initial comments included at the beginning of the function, all of them, MATLAB understands them as including information about the function itself. Okay, so when you type help, name of the function, it always returns this information. It doesn't return all of the comments because after I start writing my code, MATLAB understands that any other comment that you put afterwards has to do with describing specific functions in the code. So these are not aimed at the reader, of the function. These are more like someone who wants to take a look inside the function itself, not someone who wants information about how to call the function. So here, for example, I have a comment just above the summation that says, now compute the sum of all values. But when I call help, this part of the comment is not printed. Okay, so MATLAB understands the difference between this part of the comment and the comment that appears later on inside the code. Okay, just a detail about how you can properly structure your own MATLAB functions with comments. Okay, let's try and call this function. Uh, let's define a matrix, for example. Let's say A equals 1, 2, 3, 4, 5, 6. Okay, so this is our matrix, and let's call mat data of A. And as I said to you earlier, we don't have to use these exact names when calling the function. I just copy pasted it for speed. So we can say minimum value. I can say right here maximum value, and I can say right here sum of A. And I can call this function, and then I get, let me call this again so you can see it better. I get minimum value 1, maximum value 6, and the sum of all elements, which is 21. Okay, remember the matrix is 1, 2, 3, 4, 5, 6. Okay, so this is how we can properly structure a function with more output arguments and with some information about what it does. So let's see another very interesting function right here. It's the Fibonacci. Of course, you are very familiar with the Fibonacci sequence. It starts from 0 and 1, and then each new element in the time series of the Fibonacci sequence is the summation of the previous two elements. Now, this function includes an if loop and a for loop right here. So let me give you some basic information. The way that this is structured is not nice. Usually, we want to use indentation to make the code look better. MATLAB does that by default, but if you happen to copy paste some code from elsewhere or you don't do it initially yourself, you can mark all of this code, okay, right click, smart indent, okay, and MATLAB does it for you. So see the difference here? MATLAB has created a very beautiful code that has indentation for each different loop inside. Okay, very, very nice. So the function takes one input argument, which is n, checks if n is larger than 1, because in this case it needs to assign the proper values in case I give it an argument of 1 or an argument of 2. But if the argument is 3 or better or larger, it has a for loop inside that computes sequence I, which is sequence I minus 1 plus sequence I minus 2. Okay, very, very nice. So I have made my code beautiful. Okay, and then let me save this as well and call Fibonacci of 5, 0, 1, 1, 2, 3. Let's call Fibonacci of 15. And you see that, of course, since this is an additive formula, the values get higher and higher and higher and higher. Okay, I can save that actually inside a specific variable in case I want that. So this is just another very interesting function that uses loops inside. Okay, let's see another very fun function, which is called D matrix. So what it does, you can actually add comments yourself if you like. It takes a matrix A, and as an output, it gives a matrix that has zeros everywhere, but the diagonal elements are the same as the elements of matrix A. Okay, so how does it do that? First of all, we count the rows and columns of the matrix A. Then we create a default matrix that has zeros everywhere and the same size as A. So the output is zeros with the same dimensions as matrix A. Then I need to find out which is the larger dimension, the rows or the columns. Sorry, not the larger, the minimum dimension. So I get min dimension, which is the minimum of rows and columns. And then I have a for loop that counts from 1 up to the number of the minimum dimension, and in the diagonal element of the output matrix places the diagonal element of alpha. Okay, so let's test this function. Let's create a matrix 1, 2, 3, 4, 5, 6, And then how is the function called? Diag? No, D matrix. So let's call the D matrix of A, and this will be, okay. So it's a matrix that has zeros everywhere, and the diagonal has the same elements as alpha. Okay, so it has 1 and 5 in the diagonal. Let me change the matrix. 7, 8, 9. Let's make it 3 by 3. So now D matrix of A returns zeros everywhere and in the diagonal 1, 5, 9. Okay, so that's just another function example. Now, let's move into the very, very interesting topic of number of arguments. So here I have a great function. This is called greet. And I like this function because it has one very, very nice option that MATLAB gives us. It has a function right here that is called nargin. Okay, you see, I don't define this argument. I simply check if nargin is 0. So nargin is basically number of arguments in the input. So MATLAB gives us the option to have different commands based on the number of arguments that the user gives us in the input. And this is the way MATLAB functions work, because as you know, if you remember, for example, for control systems theory, the function like transfer function, TF, can take a single argument. So if you give it the TF of an already defined system, let's say in state space mode, it will give you the transfer function of that system. But it can also take two arguments, which is the numerator and denominator, and create a transfer function itself. So this is a very nice example of a command that can take either one argument or two arguments. And we can do this ourselves. So here I have a function that takes as an input a name. And what does it do? It simply prints hello and the name that I'm giving it. This command right here is fprint, and it gives percent of a string, and this tells us that it takes as an input a string value and prints it right at this point, and then has an exclamation mark, and then a command that says change the line in your code. Okay, so if I call it, let's say we are using greet Lazarus, prints hello Lazarus. Okay, but I want to use an alternative check where if I don't give it any argument, it will print hello friend. So I'm doing this with the number of arguments, the nargin. The nargin command, what it does, it basically counts how many arguments the user gives when he calls the function. So here where I type greet Lazarus, the number of arguments internally inside the function is 1 because I have called the function with one argument. Okay. So here it says that if somebody calls the function but doesn't give any arguments, so the number of arguments is 0, then as a value of name, use the value of friend. Okay, so if I call this, so if I say simply greet, I call the function, okay. The function is called without any arguments, okay. And then the number of arguments, this if loop checks that the number of arguments is 0 and then places the value of name equals friend. So it prints hello friend. So if I remove this, let me tell you, for example, by the way, if you mark a text, Control R makes it as a comment. Control T removes the comments. So, okay, so you can easily comment out entire sections. So if I save this and I call greet, it prints an error because simply not the function, the variable name here doesn't have any argument. So immediately it prints an error. But if I include this and I call it again, we have hello friend. Okay. Let me give you another example. And this is our final example for now. Here, for example, I have my own function to plot a specific variable, and I'm using this function because very commonly when I'm creating plots for papers, for reports, for teaching, for whatever, I want to have some big axis labels because the default value is very small. It's not properly printed in papers. And I also want to have a fat line when plotting the graph. So I'm having my own plot. It's called function myPlot. And see here, the first function returned one variable. The second function returned three variables. This one, the Fibonacci, returned one variable. The D matrix returned something, but the grid function that we said earlier and the myplot function do not return any variable. So this is another option. You can write a function that does something but doesn't return a specific variable, okay, or a specific value. So grid, for example, simply printed a result. MyPlot also does something like that. It simply prints a plot graph. Okay. So it takes as an input X, Y, and the plot title. Okay. So it plots X and Y with a fat line. It puts X and Y labels. It puts grid. It puts a box. And it also sets the fonts to size 12 and bold. Okay. So it does all of that. But it has another option because sometimes I want to plot some graphs and I don't want a title, or sometimes I want a title. So here it has another command that has a check that if the number of arguments is 3, then plot the title that I'm giving it. But if you don't include any plot title when calling the command, I simply use default title. Okay, so let's run the function and write. Let's define a variable t for time. Let's define the variable y, which is the cosine. And then let's call my plot t, y, and as a title, I'm going to use cosine of t. Okay, so it plots exactly as I told it. The graph of a function, a fat line, a grid, and very big axis fonts, very nicely. And it also includes the cosine of t as the title. Okay, so if I call the same command but without a title, now that I call it, the number of arguments is 2. So here it checks that if number of arguments is 3, which is false, it goes to the else and says title equals default title. And that's why we get printed default title. Okay, so this is only possible because I'm using this number of arguments command. Okay, for example, if I comment this out, then, as you can understand, if I call the function properly, it runs very nicely. But, oops, let me actually just include this as a line. So if I'm calling this function right now, it gets printed properly. But if I call it without a title, it gets an error because simply it goes up to this line. I haven't given it any plot title functions, no, any plot title variables, so it outputs an error. So this is what we want to avoid by using the number of arguments function. Okay, so it makes us code writing much more versatile. Of course, MATLAB has other options. For example, it has the number of arguments in the output as well. So you can build upon this with many other utilities and write very, very beautiful and very intricate codes. Okay, but these are the first few examples for me. You can test them out yourselves. You can try to improve upon them. For example, you need to add comments in describing all of these functions, which I suggest that you do. Okay, and go into MATLAB Workspace, go into MATLAB Central and try out different commands like number of arguments, number of output arguments, and play around and create many, many intricate functions. Okay, try it out yourself. If you have any issues or any problems, write them down in the comments, and maybe I'll do later a more advanced video about functions. Okay, so thank you very much.